Hi, this is Nick, who is a co-op with University of Cincinnati, and he's going to take us through the Polar 3D digital printer for educators and teachers. Hi, Nick.
Hi, how's it going? Yeah, like you said, my name's Nick. I'm from Polar 3D. We are an educational-focused 3D printing company located in Cincinnati, Ohio. We offer educational pricing to teachers. Our goal is to get 3D printers in the classroom to have students think like entrepreneurs, as well as to get them thinking about the future processes that are used in Fortune 500 companies around the world in today's time. So our goal is to get the best technology in front of students. So I'm going to walk you through a quick process of how easy it is to start your 3D print here through Polar 3D.
Thank you.
We have a, is that all you need?
No.
Okay, so we have a build plate right here. This is what your print would be printed on. So this could be a final image. Is right here. Is this would be printed on the final build plate. So it's an easy step. You would prepare the build plate with. We actually use a hairspray.
What kind of hairspray are you using?
So we use Aquanet. It's a basic. It comes with every package within the 3D printer. So this is to keep the print to stick to the build plate. So you prepare the build plate and you'd set it on here. And then it's as easy as going through the Wi-Fi. So the thing that separates Polar 3D from any other printing company is we use a cloud-based platform, which means that the communication goes where the computer talks to the cloud and the cloud talks to the printer. It allows club interaction as well as projects and uploading curriculum, so you can communicate with your classroom through the cloud. And with that, you can load your print to the cloud through an STL file that you can get off multiple softwares and send it right to the printer. So you can see right here we actually have a print in action. This is through the cloud. You notice down here there's actually a camera, so you can watch the print being formed through our cloud. That allows students to see the entire print, but also you can go back and see a time lapse. This can be used in multiple curriculums to bring basically the classroom to life. Some of the best projects that I've actually seen, many people use this in robotics. That's FIRST is a robotics club that people use it in, as well as all kinds of science and mathematics curriculums. We work closely with STEM programs and with maker spaces all over Cincinnati and all over the country to kind of bring this to the classroom. So you can see it in action. Some of the prints that we have are replication of the Eiffel Tower and some other notable things. This is actually a lift that we have. So we actually taught a class where they designed a product in a prototype and then presented it to a board of investors. So one of the classrooms taught a lift for a car jack and used it to sell to investors, and then gave the specifications, all the pricing. But really having a 3D model brings the total learning experience to life. So you can really see how Polar 3D is special. The open face printer allows the entire class to see, and the cloud-based platform allows you to print from anywhere. Actually, last week we printed all the way from Portland, Oregon, so you can really see the cloud is really something special that helps communicate and keep all the curriculum in one spot. So that's the Polar 3D model. We offer educational pricing at $5.99 a printer, so visit www.polar3d.com for more information, or email us at info@polar3d.com.
I have a couple questions.
Yes, absolutely.
I'm going to take this Eiffel Tower and ask you, the printer is $5.99, but to print this Eiffel Tower, which is right there, how much is the cost to print one Eiffel Tower?
So that depends a lot on the actual settings of the printer. So you can change the infill amount, which is how much filament you use, but we actually offer PLA filament is the filament that we use. It's actually located right here. We sell it in spools, as you see right here. They come in 12 different colors, and in doing so, it can keep prints as low as 7 cents a print, and that is sold in $10 increments or $30 for this large spool. So this, as a full spool, would come all the way out to here. So you can see that this is actually a used spool that we've used. But those can be purchased through our website as well. And like I said, it's PLA filament, so it is very low cost to print your prints.
When I was in your building last week, you were talking about other printers designed through math.
Yeah.
And yours is designed through?
We use polar coordinates. So actually most 3D printers in the market right now use a Cartesian based. which is actually basically just imagine a square, where this right here allows us to have 8 inches by 6 inches of build volume, which separates it because it runs on polar coordinates rather than a square. So imagine how much more we have to work with a square turning this way as far as build volume than a Cartesian base, which can only move side to side and up and down, where we can move all the way around.
So you're using physics?
We are using math, using polar coordinates that allows us to have a larger build volume because it moves in 3 directions rather than 2 in the Cartesian base.
How long have you been? You have a patent on this? You have a patent pending, right?
Patent pending, correct.
Yeah. And how long have you been using this?
This actually hit the market in March, so we have expanded. We're now in 39 states. So we started in March, it hit the market, and it's been growing ever since. It's been growing all over Cincinnati. We actually have been going into classrooms and teaching classes just to show how useful this is in the educational space. And
Heidi, I hope you're hearing this. I know you're hearing this part. Would you repeat that again, please?
We have been going into classrooms.
Mrs. Weber?
We have been going into classrooms and teaching classes to see just how useful this is in the educational space. Like I said, we went into Mariemont's DECA program and taught a business modeling, and they sold it to investors. We also have visited Seven Hills, CCD, and Walnut Hills in the Cincinnati area, as well as traveled to Chicago and put on a class there as well. We also work closely with the Boys and Girls Club. We would do a STEM club there for 45 minutes a day, or for 45 minutes every Tuesday in Cincinnati, as well as Washington, D.C. and Portland, Oregon. We have clubs there that we work closely with class curriculum, doing all kinds of demos and ways to incorporate technology in students' learning, just as large companies have already done as well.
Can you tell me what type of technical support teachers can get on the spot, so to speak?
Yes, so we use 2 kind of main platforms. The first one is the forum. That's through the Polar Cloud. So we like to keep everything centralized on the Polar Cloud. That keeps, that's what separates Polar 3D from the other printing companies, but also the Help Forum is a collaboration of teachers. Bringing the teaching community together is really important for us because teachers learn from each other. So a lot of the stuff that is on the forum, if they do have an issue or something that needs to be fixed, either our support staff within Polar 3D fixes it, but we notice that a lot of students as well as teachers collaborate on the forum to help solve issues that they come about, whether it be preparing the build plate or heating the extruder properly. We notice that teachers kind of work together on that, and that's really what creates, 1, the Polar community, but 2, helps bring the teachers connected and keeps the students connected. So that is the support that we offer technically. We also have a new thing that we just rolled out that's called Visita, which is an online help tool through our website. If you would have a problem that you wanted to get in direct contact with somebody at Polar 3D, that is also another option.
Is Visita open 24/7?
It is. Yeah, it's there's a call number, there's also an email, and there's also scheduling times if you didn't want to talk to somebody at Polar 3D. However, most of the help goes through the forum. That's where we like to drive a lot of the traffic because that is the most useful tool, and that's really what makes the Polar 3D brand special.
So the Innovator is from Cincinnati, Ohio, correct?
Correct, yes. The Innovator, the actually creator of this Polar 3D model is a retired Microsoft computer engineer, and he wanted to make a 3D printer that was useful in the educational space. So you can think about how well thought this is. If you look at here, you can see that all students can see from different angles. It's also safety proof. If you look at it, I can touch anywhere around here and my fingers can't get burnt. The only place I have to be careful is down here by the extruder, and that's just like a hot glue gun. You wouldn't want to touch the tip of a hot glue gun, but you wouldn't want to touch the top of this because it's heated to a certain degree to melt the PLA filament. However, it keeps students from jamming their fingers in anything and makes it safe. The big thing too is it's very durable. So we like to make a product that's, 1, low cost because so we can afford it in the educational space. 1, that's durable because we understand that the classroom, it is around a classroom environment. We realize that not everything is safe. Stuff can get bumped, desks can get knocked. So if it does get knocked, it just can realign. And then also, we also like to have that it's reliable, so we don't want to have a bunch of jams in here, so we made a printer, that can back out the filament if we want to change it, that we can heat it up if it gets stuck. So we make a lot of adjustments to the printer so that it does work in the educational space, and that all students can see it. Why would we put a box around something that we want everybody to be able to see? And if you can't see it, then you can watch it through the camera on your computer, and that's really what's special, is the ability for all students to get engaged in one activity.
So students learn from their mistakes, especially in innovative projects. Does the machine stop how does a student know the student's made a mistake?
So you would see that there's a mess up in the build, and that is where you would stop the printer manually through the cloud, and then you would go back and fix what you find. So a lot of it is fail and then succeed. So that's one of the best ways to learn is what are you doing wrong? How are we going to fix it? And then when we fix it, look at the great thing that you have done. You can show, one, the progress in the learning, but also how incredible it is to work with a machine that you possibly could use once you graduate college and implement it within companies. So learning from your mistakes is the best way to learn. And really with Polar 3D, we've seen a lot of students grow through the CAD software and the printing software, just understanding what is going on and then how they can innovate in the real world.
Okay, it just switched up on me. It was going this way,
right,
and now it turned that way.
Right.
Why is it doing that?
So the computer sends signals to them to move in different directions. So we can move in the Y, the X, or the Z. And right now the computer is laying different layers of filament in different directions, and as a result it shifts on the Polar 3D's main axis to make sure that it's the most efficient print and also hitting the right areas. So it was going this way to work on this nozzle, and then it switched to make them more efficient on this side. So you can see that it runs completely on coordinates to find the best location, the best placement of the filament.
And the length of the time for a typical project.
Right, so something like this would run an hour and 30 minutes would be the full print.
Okay.
But something like this that uses 8 inches in diameter and 6 inches in height, printed in 23 hours. So this is the largest print. Yeah. So this is the Polar P right here.
Polar P.
And so this is the largest build plant that you could put. It fits directly on this, and it took 23 hours. But little projects like this whistle can take 30 minutes. And one of the things that we did is the gymnasium teachers at Claremont High School, we made them whistles. So we didn't even have to purchase $5 whistles. We actually saved them. This costs 5 cents to print, and now all the gym teachers have whistles. So you can find ways in the
Go
school.
Warriors!
Yeah.
Warriors change the world.
Yeah.
one day at a time. Of all the innovations you've seen over the past year, is there one that stands out to you?
You mean as far as design?
Yes.
So this one's particularly my favorite. This is actually a 3D scan printer of the lead engineer for Polar 3D, and this is a 3D printed image of actually Bill Steele, who's the actual inventor of the printer. He printed this on a Polar 3D model.
That's Bill, huh? He's a superhero.
So you can see even the incredible detail all the way down to his pants, where his pants ripple right below his kneecap, to his shirt tucked into his arms. So you can see that that's one of the best things that I think that's the coolest thing, is really bringing something to life. That's a 3D image of a person that's actually brought to life on a 3D printer. So you can see how cool that is.
That is the guy who invented or innovated this Polar 3D. This is Bill Steele. And how many times did he redo this?
This actually, if I'm not mistaken, yeah, it was acceptable the first time. I was actually in the office when he did it. So.
I want to show the dog. That's cute. Did you guys do this? Or
Yep.
A student do it?
These are all designs that we did in the office. So we have a little polar farm there. It's where we just have a bunch of printers running. So this is a pretty cool one as well. This is neat just to show. This is googly eyes. So you can see this actually was all 3D printed. So.
That's very cool.
So yeah.
I'm trying to think of any other questions that this was.
Yeah, and like I said,
making an apple. Another apple.
That's a rough. Yeah. So this is actually the apple right here. You can see the detail even down to the leaf. It's printed on there.
They give teachers these apples, which are very cute. I might want to stick a pencil in there.
So yeah. But yeah, those are.
Okay, one final question.
Yeah, absolutely.
what age group are teachers beginning to use this printing system?
Yeah. So we've actually seen the entire educational space start to use these all the way down to a kindergarten level. It's really, the sooner that students can start seeing this, the better off they are, because they can see that the technology that's being used all over the world at the youngest age possible. It varies in age groups. We're all the way down, like I said, to kindergarten, all the way in colleges across the country. So we'll be in several colleges here, and just all the way, like University of Cincinnati has one, Purdue will be doing one soon, University of Toledo got one. So it's been used
You have
all
one
different
out of
levels.
UCLA?
Yeah, we need to get one out of UCLA.
Yes, you do.
Go Bruins.
Go Bruins.
So,
Did you hear that, Brittany?
so yeah, that's all the way down any level, really. And there's different ways to implement it depending on the curriculum that you build around that. So we've been focusing on curriculum for different age levels now, and plan to really make it a special learning experience.
I appreciate you
Thank you.
going through this with us.
Absolutely.
Some teachers aren't able to be here today, and so I thought I'd share it this way with us.
Yeah, if you have any questions, info@polar3d.com or polar3d.com for our main website. So thank you for listening, and I hope you enjoyed.
Thank you. Anybody have any questions?